Hello, everybody. Welcome back to Build Stuff Live, Offline and Online 2021. Big hello to all the folks out there in Vilnius watching us on the big screen.
Hello.
Big hello to all the folks all over the world watching us on, let's face it, probably a slightly smaller screen than the ones in the Kinoplex Cinema in Vilnius, even though I know some of you have us on the 44-inch Samsung widescreen displays. It's great to see all of you. Thank you for tuning in. It is my great pleasure to welcome up next on our Jupiter virtual stage here, talking to us about retrofitting legacy Java apps with a reactive flow pipeline. Please welcome Fabio Tiriticco and welcome back, Mary Grygleski.
Hello.
How are you doing?
Hello.
Good. How are you?
Good, thanks.
Glad to be here.
The stage is yours, friends. Have fun.
Thank you, Dylan. Thank you. So yeah, everyone, welcome to our talk today. As such, thank you to Dylan for giving us a very nice, warm introduction, and Simon in the background doing all of the work for us. So thank you for the organization. So today we're going to talk about reactive, but we want to inspire you with this concept. So here we are. We're going to kind of suggest, right? You can retrofit your legacy app, Java app, with a reactive flow pipeline. So with me is Fabio, and this is what we're going to plan on doing today. Let me kind of advance the screen. So this is our agenda for today. I'll do a bit of an introduction and then talking a bit also about why we're doing it, right? From the 2000s to we already started to have enterprise JVM applications. And the amount of problems that we have in today's world is just going to ever evolving. It's getting more and more complicated every day. Everything is distributed. So I'll be talking a bit about those. Then I'll pass on the stage to Fabio to present a particular use case using a demo of like a simplified pipeline, but kind of complicated enough to be able to show it to you today. Then we'll kind of come back together and have draw some conclusion. But first of all, let's kind of do a bit of quick introduction. So Fabio, if you want to start.
Hey, everybody live and remote. My name is Fabio Tiriticco. TicoFab is my handle on Twitter and pretty much everywhere. I come from Italy, but I'm based in Amsterdam, where I work as a software engineer and now actually a software engineer manager. But I also run this community called Reactive Amsterdam. In fact, I am so glad that there are hybrid events happening. I can't wait to go back to fully, the full live experience. So I wish I was there, in the flesh among everybody.
Yes, yeah. Thank you, Fabio. Yes, I hope the same too. We've been all longing for in-person interaction, but this is nice to have an hybrid event, and then we're still talking remotely, but hopefully next year, maybe, who knows, right? We'll have a chance. So yeah, so my name is Mary Grygleski. I'm a senior developer advocate at IBM, currently with the WebSphere Liberty team, doing mostly like open source Java, DevOps, and cloud, and all of these things. And my interests really are in distributed enterprise systems. I'm also the president of the Chicago Java Users Group. And just like a little quick intro, how myself and Fabio came together was that we met at CoMotion in Italy, in Rome, like 2 years ago. And then we kind of like hit along with each other so well because we were both passionate about reactive systems, reactive technology. And then we thought, well, let's do some talk together. So here we are. Okay. So let me then start without further ado. A bit of introduction, right? And why are we doing this like a talk like this? Because we find that it probably will be very inspiring to explore into using the reactive approach to help to modernize your older application, right? The legacy kind of applications. So traditional enterprise JVM applications, as we all know, mostly, right, about monoliths, right? You're kind of having, let's say, a single JVM, and then inside you're hosting all of your components, separate components. So anytime if you want to make any changes to any one component, you have to have everybody kind of work together at the same time. You need to do deployment, then basically you have to shut down everything and then do kind of reboot and refresh and do all the deployment first, of course, and then basically refresh your whole server. So, it can take really hours, which means you're going to be, your whole system can be down all at the same time. Or even if you have like low balance, you have another one running, kind of duplicating. But this kind of process is really in a monolith environment is not very conducive, right? In like today's environment, when we need everything to be fast, it's a cloud native environment, a lot quicker, and everything is not loosely coupled. They're tightly coupled kind of thing. So that's why we want to explore into this reactive way of doing things. And the thing is with reactive too is also fits very well into doing, say, microservices, that architecture. So we'll kind of take a little quick look into that too. As you can see, right, in today's world, we're dealing with systems that are highly distributed. If you look around too, like what systems are not distributed these days, right? Everything is all distributed everywhere. So there's got to be like better ways of how do we deal with like concurrency type of issue, asynchronous issue. And then not only that, right? Especially when we're dealing with data in volumes too, you can say, well, we can happen all at once and data coming in, streaming in, but there's always this issue of back pressure, right? You're like streaming things in, then you need to have some mechanism of dealing with all of the data coming in all at once. You don't want to have any bottleneck and then basically creating a situation of your system kind of being choked, kind of like that. So that's why too, it kind of prompted us, we feel reactive systems as a very good it's positioned very well to help and lead systems into the new kind of age period in when we have to deal with so many things all at once. So as such too, I already talked about this, right? These are very complex systems in an ever evolving world, right? If you think of, let's say a system that I've worked with, I deal with like mobile app kind of front end, and there are also desktop app and everything. And then they're all kind of trying to request certain functions from your running system. It can be an e-commerce, very commonly used system will be, a use case would be an e-commerce systems. These systems too can have multiple databases and running in multiple different let's say in the Kubernetes world, right? Everything is all containerized in different, pods and worker nodes and everything in your Kubernetes. So very, very distributed. We have to try to solve these problems. Again, with huge data coming in, you can be one side doing all of the data, feeding into the system, another side is processing, and they all have to have, they can all be happening at different times, but you want to have a good way of how do you like synchronize all of them. So we have to deal with this kind of issue, right? The concurrency, asynchronous type of processing. So now then, let's take a look then in solutions of using this reactive approach. Here, actually, I don't have this slide up, but otherwise too, folks, just to give you a background if you are new to reactive systems. So reactive systems essentially follow the reactive manifesto, which is a set of guidelines that spell out the 4 core principles of what reactive systems should be. So namely responsiveness. So your system has to be able to respond to requests really fast. There's no downtime. So what if there are issues happening, right? Network is never reliable, as we all know it. You can have issues, right, that crop up and you need to recover, quick recovery, or the cases in which you can have many requests coming in, you need to like quickly spin up a lot more components or worker nodes or essentially worker threads to kind of help like process all of these things, right? So, and as such too, reactive systems will meet this kind of requirement of scalability too, and also resiliency. So if any components go down, you want it to get spin up kind of immediately, really fast. And then the 4th kind of principle of this reactive systems is that the whole system has to be message driven. So everything is all the data being handled as streams, as it's not the traditional way of doing things. And we're dealing with data as streams and all of these things. So the streaming side, it really works very well if you're talking about a message-driven kind of systems. They're always sender and receiver. You need to have a mechanism of kind of coordinating these quite well, but they are all kind of can be happening at different points in time. The time is actually one of the element, and the space and time kind of this kind of concern. So anyway, so kind of let's go back to, right? So we can, in today's world, cloud native, we're all talking about containerization, talking about microservices. So how about then using a reactive approach, and then using this streaming approach that will also help you to deal with like back pressure issue. And in fact, reactive Streams is such a specification that just came out from the Reactive Foundation, which was just formed in, I believe it was 2019 or 2020. Very new Reactive Foundation supports a Reactive Streams specification. It's basically specify how reactive systems should handle back pressure and essentially dealing with asynchronous processing in a reactive manner. So, okay, so then let's kind of take a look a little further. Then essentially too, in a cloud native world too, we also specify the using DevOps, as the mechanism of helping to deliver, to do continuous build, continuous integration, continuous testing, and continuous deployment. So this is also kind of like a new way of doing things. So it kind of goes against or kind of an enhancement towards the previous traditional way for like monolith system, in which you have a huge production team or delivery release team that handles all of the build, testing and integration and all of these things until deployment. So we're also like using a DevOps way of handling things. So reactive too can fit very well in this manner, right? We do builds and essentially you can kind of hook up, your source code system, and then it will kick off all of the build and integration and testing continuously too. And as such, right, so it helps with the like quick release cycles. And basically too, on the coding level too, because of the way how reactive kind of handles like the way the processing is, you don't actually have to worry about threading as much like explicitly, because the systems already is handling all of these threading concern for you kind of behind the scenes. So that's what it's kind of like a good approach, we believe, right, to use reactive. But yeah, without further ado, let's kind of take a look at the this particular test case that Fabio kind of took some time to kind of develop it. We're doing it sort of as a side project too. So thank you, Fabio. I'll kind of let Fabio take over at this point and talk about this demo.
Yeah, thank you. Thank you very much, Mary. I'm going to share my screen. Okay, excellent. Now you should see my desktop background. Great. Here we are. The last slide that you have seen from Mary's presentation had this very image here. And while this is the GitHub repository of this project, what we are going to look at is a reactive pipeline where we suppose we have two legacy apps, in this case, two legacy processors, these yellow and red blocks. And the idea is that these legacy processors will, each of them, receive data from somewhere and then output some data after processing. The initial source will be a Kafka topic, then legacy processor 1, processor 2, and legacy processor 2 will output its data on the second Kafka topic. If you're curious to look at the GitHub project after, you will see that each project is basically split into its own folder here. These two, infra and sources producer, are sort of plumbing projects to just spin up the infrastructure, the Kafka broker, whereas the real deal is in the two legacy processors. Let's first give a bit of a look at the code. Nothing to be scared of, really quite short. What's important to notice is that because we will be using the Reactive Streams protocol specification, in reality, one of the legacy processor is a Scala app, and the second one is a Java app. And this just goes to show a little bit how different technologies, different runtimes, if it was a JavaScript app, would be the same. They can interact fully in a fully reactive way. So this is our first legacy processor. And what's going to happen, what you see here is a little bit of configuration, but then these 4 lines is all I want you to look at. We are using Kafka Streams here, which is a tool developed by Lightbend on top of their Kafka framework to basically express our logic in terms of streaming, where if we look at these 4 lines, what we are going to do is we are going to connect to a Kafka topic using some settings. And then each item that we get from the broker, we are going to process it. And this simulates our legacy logic. And then we're going to put the outcome of our processing on to the next stage. And to do this, we are going to use a protocol called RSocket. I'm not sure how many of you are familiar with RSocket, but it's like an emerging native reactive protocol. You can see it as a bit of a competitor of HTTP. It really is an application level protocol that, in addition to HTTP, also has direct streaming capabilities built in. So you can, emit a stream of events, or you can emit only one event in a request response fashion like HTTP. And what's beautiful about it is that RSocket as a protocol implements back pressure from the ground up. And back pressure, like Mary mentioned, is that basically agreement between a producer and a consumer, where the consumer can slow down the producer if the rate of input from the producer is too high. So if a consumer is too slow, can ask the producer to, hey, please slow down, I cannot keep up. And what's amazing about back pressure is that it propagates across all the steps. So if we go back 1 second to our schema of the different processors in the pipeline, if, let's say, we have back pressure enabled at this point here, and this arrow here, well, this back pressure will propagate all the way back in the chain. So if one consumer along the line is too slow, this will cause every step before that consumer to slow down. And we're going to see this in action in just a couple of minutes. So the legacy processor 1, that's all there is to see, really. Let's look at the legacy processor 2. This one is a Java app, as I mentioned. And of course, being Java is a little more verbose than Scala. But what's important to see is what we are doing in this file. This is all the only one file, basically. We are creating a RSocket server that will receive elements from upstream using, TCP. This is just a implementation detail, and will deal with every incoming item using this logic here, acceptor. And this logic here is defined just above. And this block of code is basically telling us that for each item that we receive, we are going to do some processing with it. This again simulates some processing logic, and then publish our outcome to our destination topic on Kafka. Now, the key thing here is that only when this method returns, so here, this body here, only when we reach the end and we return this value, only then the producer is allowed to send us more data downstream. So if there is something happening here, something that takes time, and we just don't return this value just yet, the producer is not allowed to send us anything downstream. Now, as you will see later, this processing here can take a variable amount of time, and you will see what happens when this becomes very slow. So let's start things up. Let's bring up our Kafka broker on my local machine. There it is. And at this point, I can start the sources producer, which is just a sort of fake little project that will publish one item per second on the Kafka topic. There it is. See at the bottom, it's just pushing one message per second. Now, on this side of the screen, we are going to start the first legacy processor. There it is. So what's interesting about this first legacy processor is that there it is. It started, but it's not doing anything. And you know why? Because it's looking for a consumer at this port, very hard-coded for the demo. It's looking for a consumer, but there isn't a none yet. So what we're going to do now is start our consumer right away. There it is. This is a Java app. All right, so now the second legacy processor is started and the server is started. What it's doing is just sitting idle here. And while the first legacy processor, there it is, they found each other. Okay, so let's study a second what's happening. The messages that are received by the second legacy processor take sometimes, most of the time, 1 second to be processed, but sometimes they take 5 seconds. And so what you will see now is that when we have a 5-second processing message, the first legacy processor is also going to stop consuming. See what's happening? So while this guy, the second legacy processor, is busy processing, because that method hasn't returned yet, like now, the first legacy processor is stuck. So yeah, now we're stuck at offset 35, consuming from Kafka. And only after this is done, we can move on. And this is a concept that it's really, really powerful. In my experience, it's really powerful. And to go back to the initial idea of protecting your legacy application, sort of retrofitting your legacy application with a reactive pipeline, well, that's exactly what we mean. If we can protect our legacy services that can still do the job, but maybe they're not very, they're a bit old, they cannot scale very much. Maybe inside there's a very inefficient usage of resources or something like that. This is what really can help you. All you have to do is create this little shell around them and protect them with back pressure. If you do this with all your things in your pipeline, even for pipelines that are a lot more complicated than this one here, well, then you are in a great place already. And with this, I am going to, this was all for our little demo. I'm going to stop sharing my screen and give it back to Mary for a couple more considerations.
So thank you, Fabio. You took the time to explain this. We're going to go to the next one. Let's then talk about some experience from building this pipeline, right? So essentially, too, the reactive streams, right, standard has enables like different technologies to work together. So that's like really nice. As you can see, right, Fabio did that. One part of it is a Scala, using a Scala way of doing the processing the data, reading from Kafka, and then producing the messages. Then it's actually going to be picked up by Java, by another Java in the pipeline. But you can write anything. You can have JavaScript. In fact, Reactive Streams also kind of essentially supports all kinds of languages too, like RSocket as well. It also supports many other languages as a polyglot type of implementation you can do. And so it's really convenient. Think of it sort of like Lego pieces too, in my mind. It's like you can have different kinds of pieces, of your Legos can be different, shapes and size. And as long as the part where you can integrate them, in this case, is using like a Kafka type of construction, kind of in the beginning, the construct, and then you have your reactive output, of your data. It will become input to another component. And then likewise, too, you can basically chain up this whole pipeline according to your needs like that. So it's really nice. Okay, so, but the thing though, I guess for the experience from doing this, I mean, theoretically, it's great, right? But these are like really emerging technologies. So some of these parts of the system, I guess, especially with RSocket, I remember when Fabio was initially looking into the RSocket, he said, this is very hard to do. And I think he's laughing about it already, but it's just, it's being so new. So then you have to work through some of the kind of idiosyncrasies with that particular library too. So maybe you can share, if you have a word to share, Fabio, about your experience with the RSocket.
Yeah, sure. Indeed, in the first legacy processor, if you remember, what we have is a source from Kafka and then an output using RSocket. So both these two, like say, connectors are Reactive Streams enabled, but they are different. So RSocket implements it in a way, and this Kafka Streams connector implements it in another way. So to make this sort of work together, it's not as easy. I didn't find it as easy as it's advertised sometimes. And in particular, Kafka is, of course, battle tested, and there's many tools, and I'm sure many of you in the audience use it. But RSocket is kind of a new technology. It was initially introduced by Netflix, and documentation is what it is. I mean, we are all software developers, right? So there's not a lot of documentation out there. Examples in the repo, the tests maybe are useful, but of course limited. And in particular, the Java implementation, which I used, relies on Project Reactor, which, to be honest, I found to be a little of a limitation. Like if you come from a Spring background, sure, you'll feel right at home using all that mono and flux and all that streaming semantics, but maybe you don't like it. Or maybe you come from a different place and you've never heard Flux in your life. So then you have to learn it. So it depends. It's not incredibly flexible. In fact, as a final consideration with my experience, I would say that HTTP, as I mentioned during my talk, is not built for streaming, really, at least not HTTP 1. But you can put something on top of it. Like Akka HTTP, for instance, is an HTTP client that builds streaming semantics and back pressure on top of HTTP, and it's almost transparent to you, because at the end of the day, all you're doing is post requests. So yeah, that's my experience with RSocket. Recommended, but maybe not very mature yet.
Yes, that's right. Yes, I believe there's still the foundation, Reactive Foundation is still like refining and having new versions of the RSocket protocol, kind of still being in the works. But I do believe perhaps given a little bit of time, the maturity of the library itself will happen, I think, and that's what I think. So yeah, very cool. Thanks, Fabio. So yeah. So then let's kind of get to a bit more of an conclusion at this point, right? Summarizing all of the findings and what are the alternatives and how about Project Loom. So let's kind of talk a bit too between me and Fabio too. So I think as such, right, my feeling is that like using a reactive approach is definitely something very new, and maybe a lot of folks too are not as familiar with it yet. And I think maybe even like reactive way of doing things is still, I think it's still not like has taken off as quickly as it is. I mean, I guess as such too, currently, all of the systems are complex in itself. And if you have to try to re-architect everything so big, and then let's say you just want to do it in reactive, then how do you do it, right? And that type of stuff. But I think the suggestions would be to start your modernization, projects. Start it small, maybe target certain functionality of your system and start with it. Maybe if you can identify using a reactive type of approach, especially when you are streaming a lot of data, going in and transforming your data and then going out to another parts. If that can be done, I feel that it would be a good way to kind of slowly transform certain components of your system and using it the reactive way. I think that's a very viable type of approach. And then and then there are also then we're kind of thinking too, are there any other like alternatives, let's say to this approach, to the reactive approach? I think, or what do you think, Fabio? Do you have comments on this part? Yeah, since we started doing this talk, it's also been changes too in the marketplace. We started doing it in February of this year, and not knowing it's already November of 2021. So we are also kind of working, with different technologies. And have we discovered any other ways to kind of do this type of, application, or maybe, are there any alternatives, right, to doing it, like breaking down your monoliths and then using a reactive pipeline? Do you think there's any other ways to? So
what I'm seeing is that serverless is becoming more and more prominent, and so the idea is where you have this sort of on-demand thing where maybe your resources are not permanently used. There's a request coming in, some execution, and then the whole thing dies basically until the next request. So I think there is a push of abstracting this resource management. Reactive approach is very good for resource management, but maybe there are some alternatives, like Akka Serverless is one of those, where they sort of try to abstract this entire management and let you focus on your business logic. So on one hand, maybe you don't need to learn this pattern at all if you don't have a compelling use case. I would say this is the good alternative to reactive. But yeah, if you're a software engineer and you like learning things, then it's still a great tool.
Yeah, totally. Yeah, I think too, I think I would be more excited about just learning about new ways of doing things. There are always alternative. There's not only one way. There just can be an infinite amount of ways. Some of the ways are still, yet to be discovered or kind of created, and so to speak. And so I think it's an exciting area, and certainly Reactive should be able to also offer you a lot of the benefits of using this kind of approach. So then there's also then lead us into another kind of subtopic alongside is about Project Loom, which is like from the Java, the JDK, the Java movement, so to speak, right? All of the Java specs are from the community. So, right now, actually, only 2 days ago too, I thought I read somebody tweeting about Project Loom will actually be in Java 19. And as such, if you are into Java, you are aware of Java 17 just came out in September. So with the 6 months kind of release cadence, the March will be 18, then next fall, which is September of 2022, then we can expect Java 19. So I think I've read somewhere, somebody tweeting, there will be Project Loom will be in that release. In fact, I also read too, they said the name would be changed to just simply virtual threads, rather than calling it Project Loom is actually virtual threads. So essentially that's what it is. Project Loom is about virtual threads. So yeah, and actually, just to quote to what I heard from Venkat Subramaniam, who's a very prominent speaker, right, in all the programming languages, really high. I hold high respect for him. He's such a great human being too. So I remember he made the comment was so good. He said, "Well, Project Loom is kind of like." Virtual threads is enabling you to write imperative code, but yet it will be executed in a reactive kind of declarative way. But you can continue doing things the same way, writing like how we write code today, synchronous, not necessarily using functional style, but it will be processed in a very reactive kind of way, right, of doing kind of all of these functional style streaming type of programming way of things. So that's kind of an interesting thing. And have you heard anything too about Project Loom? Since we last talked about it, right? Things change so fast, right, Fabio? So.
Yeah, I'm really curious to see what really comes to be. I believe that Project Loom will be on paper, it will be a great complement to the reactive approch, but it will not make it obsolete. At least this is my take. Working with all legacy and synchronous things a lot easier. Let's say you are still stuck with JDBC, then Project Loom might make it a lot more efficient, a lot more like sort of friendly and more resource wise, a lot more efficient. But it's not going to remove all the thinking of this asynchronous thing. I mean, a virtual thread, you still need to know what do you do when the operation is completed? You still need to build things to, in this uncertainty world, a thread, maybe you don't know when it completes its job, and you still need to build your things around, that you don't know when the thread completes.
Yes.
These kinds of things. So I'm really curious what it will come out. I think it keeps changing over time too, so it's a bit early to judge.
To tell. Yeah, exactly. That's what I think too, Fabio. I remember earlier on, we were looking into Project Loom, and we feel somebody was saying that Project Loom can replace Reactive, but I think in fact, it's a different, we're targeting different problem areas within the same kind of space. So yeah, it won't take over, but it will be kind of complementary of one another. Reactive, systems can be sort of like retrofitted to work with Project Loom, to work with virtual threads underneath.
Exactly.
That's what we think, right? Yeah, that's right. Yeah. So yeah, wonderful. So, okay, so I see that we have about 5 minutes left. So let me then quickly bring to the ending part of our talk, so then we can leave some time for Q&A. But so this is like a list of all of the resources that we like to share with you from this talk, including the code. And I've already shared the code on the chat too for the GitHub, but here it is again for the GitHub repo and the Reactive Manifesto, Kafka Streams that Fabio was doing some work on, and our socket. Quarkus too, there's also another interesting framework that allows for both mixing of imperative and reactive coding from Red Hat. So, and then also Docker too. Docker is indispensable in all cloud native systems these days. We're containerizing, even though, okay, Docker requires payment, but I think it's still there. Otherwise, there are other alternatives such as like Podman that will be free like that too. So, okay. And then with that comes to the end of our talk. So we still have a couple minutes, but if you'd like to stay in touch with us, and we really welcome you to, kind of stay connected and share your project ideas or thoughts or comments with us. So again, this is how you can reach us. We have Fabio, all the links here up top, and then I have it in here. And I also, just a thing to point out, I also have a Discord server if you want to have conversations too. I also have a community of a bit of over 100 people right now. And we just share ideas and just even tech jokes too. So anything, I'm very, open to that. I also have actually a weekly live coding Twitch stream on IBM Developer on Wednesday as well, if you're interested, and I can share with you on my Discord. So yeah, so welcome. I mean, thank you again for having joined us.
Thanks, everybody.
Today. Yeah, thank you. Yeah, so we can also take a look, I guess, to see if there are any questions right now.
Yeah,
or
we can join the Q&A on Zoom.
That's right. Yeah. Okay, we will.
Thanks, everybody.
Zoom, right? Okay, cool. Thank you. Thank you so much, everybody, for coming in. Thank you, Simon, for helping us, and Dylan too. Let's leave. So, okay, thank you.
Bye.
Bye-bye.